Hello, and welcome back to Part 4 of the 2020 College Football Season Network Profile Summary. Once again, I am Major Andrew Dietz, and we will be using graph theory to explore trends and analysis of the 126 teams in the FBS division of college football. As before, the network displayed before you is recompiled weekly and represents every team as a vertex on Graph H, and each game played between two teams is represented as an edge on the same graph. Here we see the network as it has grown through the first 8 weeks of the season, and we are starting to see more heavily populated components as conference teams continue to play one another, and some of the teams' node sizes are increasing as a function of their number of wins compared to other vertices. In the last segment, we explored the concept of degrees, and one of the applications was showing how the degrees of the vertices of different neighborhoods could relate to the strength of schedule, highlighting differences between distant teams with similar records. In this segment of the network profile, we use isomorphic neighborhoods to find parity between teams instead of differences. But first, a quick recap on how isomorphism applies to the network profile of the 2020 college football season. Two graphs are said to be isomorphic if and only if there is a one-to-one correspondence of the vertices from the first graph to the second, and all edges and non-edges between them are preserved, such as in these isomorphic two regular graphs. Applying this concept to the college football network, let's look at the induced subgraphs created by the teams Oklahoma, Wake Forest, and Virginia Tech, and the teams they have played and the teams those teams have played. These three teams all have the same 3-2 win-loss record and have very similar neighborhoods. But if we're interested in finding teams with parity in their strength of schedule, we can look to see if any of these induced subgraphs are isomorphic. Using the typical checks for isomorphism on these three graphs, we first check for the number of vertices, which in our case is our team of interest, the number of teams that team has played, and the number of teams those teams have played. Then we check for the number of edges, the total head-to-head matchups between teams in each subgraph, and finally for graph structures such as the number of unique paths of the same length between teams or the number of cycles of the same length. While it is immediately clear that none of these graphs are isomorphic to one another, the subgraphs created by Wake Forest and Virginia Tech are much more similar to one another than they are to the subgraph induced by the neighbor of neighbors of Oklahoma, and a game between these two teams may be a better matchup. As the season matures, induced subgraphs of this order will quickly become impossible to find by hand, but with the aid of some automation and built-in NetworkX functions, we can scan the entire network for isomorphic induced subgraphs centered on specific teams and help recommend potential team pairings. While the overall season is only a little more than halfway over at this point, many postseason bowl games are already attempting to determine which teams to invite to play. While some of the teams that will play in the marquee bowls are pre-selected by conference championships, other bowl game planners may find tools like this beneficial to help find pairings of teams which have similar matching as an indicator of their strength of schedule and ultimately a more interesting game to watch.